Hi, my name is Steve Gemini. I'm an instructor for ATI's Ground System Design and Operation class. This class is a 3-day seminar. It's offered either on-site or it's offered as public class. I try to teach this class several times a year. I've been teaching this class since 2003, updated periodically. The class is a full description of ground system design and operations. The class is compiled of experiences from my 30 years plus as ground system engineer, initially in 1980 for Communications Satellite Corporation, designing Inmarsat ground stations, both shipboard and transportable. Ultimately, 10 years at Johns Hopkins Applied Physics Laboratory, where I was lead ground system engineer for the NASA's New Horizons mission to Pluto, which will be going through Encounter this July 2015. Also worked on NASA's timed spacecraft mission studying the Earth's upper atmosphere. Was lead ground station engineer on that, responsible for a 60-foot dish antenna that tracks time between 2 and 4 passes a day since 2001. The course outline for this course starts off with a table of contents, covers topics such as link budget, ground station architecture. We'll talk about the elements of the ground system, talk about figure of merit. I cover a section on modulators and modulator basics. I have a brief segment where we introduce the concepts of ranging and tracking, orbital element sets, orbital shapes. We'll talk about ground systems networks and standards. These include NASA's CCSDS standards. We talk about various different ground system networks for hire that are available, including a deep space network. We'll also go a little bit beyond the ground station and talk about some of the other than physical layers in the OSI 7-layer model. These include the coding layer and transport management layers. A couple of last sections conclude with trends in ground system development. These are new advances in technology and imaginings of what may be if the trends continue in future years. I introduce a sample link budget calculation where we look at candidate examples of various different transmitter power, path loss, ground system G over T, and look at that impact on the overall ability to meet system margin. We'll look at an overall block diagram of the ground station and the components that make it up, including up converters, down converters, high power amplifiers, and their impact on each other and the system performance. We'll talk about the G over T of a system, how that's calculated, the parameters that are important in doing that calculation, including the noise contributions of various different components, including a high power amplifier if it's used for transmit. And we'll talk about the way those noise components are reduced by various different losses in the system and how noises after the reference point are dealt with to bring them forward to the reference point used to calculate the G over T. Also provide a sample spreadsheet of the G over T calculations based on a real-world example of an actual operating ground system, and interactively go through and change things like antenna gain, noise figure, HPA contribution, and decide how that affects our overall ability to meet system specs. When we go through talking about ground system components, we'll also discuss antennas, different varieties of antennas and reflectors, and we'll discuss how the antenna temperature is calculated, how it's arrived at, and its impact on the overall system performance. We'll derive various different examples of antenna dish gain and how that plays into calculating system performance. When we discuss tracking and pointing systems, we'll cover several different examples for auto track and maintaining position of the spacecraft within the beam of the antenna. These will include open track, open loop, step track, and monopulse tracking. Talk about low noise amplifiers that are impact on the system figure of merit, or G over T. High power amplifiers, including traveling wave tube amplifiers, Klystron amplifiers, and solid state amplifiers. We cover the frequency conversion process. We have a brief section that talks about modulation, modulation basics, where we discuss AM, frequency modulation, and phase modulation. Some examples of the phase modulation slide. We talk about digital communications and coding, and the way that digital communications can be affected by noise and the impact that that has on the overall quality of the system communications. We'll talk about modulation and modulation formats for digital signaling constellations, including BPSK, QPSK, and QAM, and their impact on noise. When we talk about CCSDS, we use the CCSDS packet telemetry model. We talk about all the different layers that CCSDS implements of the 7-layer OSI model. We go into some bit busting. We take apart the telemetry packet structure. We look at the framing and the formatting and the segmentation. We'll go into the actual bits of the CCSDS packets and understand how they can be optimized for various different applications. Typically, this would be NASA science missions, although most of the worldwide science community also uses CCSDS. Military is a late adopter, but even military spacecraft are beginning to include CCSDS as well as commercial. We have a section where we talk about CCSDS file transfer protocol with some graphics that were produced from the CCSDS documentation that show the concept of moving files in an FTP-like manner between spacecraft solid-state storage and storage systems on the ground. Talk about encoding, forward error correction, cover convolutional encoders, systematic block encoders, and we take a step outside of the ground station and look at the larger network, how the ground system can be distributed and broken in different ways across a communications network infrastructure, doing different parts of the framing and packetizing at different locations. Pull up an example of the timed mission and the spacecraft and ground system block diagrams. Pull that apart in pieces so we can see where the different parts of the system fit together as a whole. Generally, I've been getting very good responses to this class over the past 13 years. I have a lot of customers that come to this class because of recommendations from other people who have taken it. Welcome the opportunity to see you in class or to conduct a class at your facility. Thank you.